This paper will discuss the concept of MAC, most appropriate construct for cuff repair. Step 1 is to assess the tear mobility. This is done using a tendon grasper from the anterolateral or lateral portal. Here is an example of a tear with good mobility. Here is an example of a tear with poor mobility. Step 2 is to assess whether the tear reduces anatomically. Here is an example of an anatomic tear reduction. Here is an example where an anatomic tear reduction is not possible. Step 3 is to assess the tear reduction vector. Here is an example of a tear that reduces best from the posteromedial to anterolateral direction. And it's only until it's pulled from posteromedial to anterolateral we can see the tear reduces correctly. Here is an example of a tear that reduces from the anteromedial to posterolateral direction. Here is an example of a rare tear that reduces from the direct medial to lateral direction. Here is an example of a complex tear that does not reduce in a linear tear reduction vector. We can see here using the tendon grasper, it's really difficult to appreciate what an anatomic reduction would look like. In fact, the tear probably needs to turn the corner in a nonlinear direction. Step 4 is choosing the most appropriate construct for the tear. In a tear with good mobility and where an anatomic reduction is achievable, in a linear tear reduction vector such as this one, a linked double row repair can be chosen. In the case of poor tear mobility and a non-anatomic reduction, such as this tear, a medialized single row repair with free ripstop sutures is chosen. The footprint is medialized, first with a radiofrequency device, and then with a burr on reverse. As you can see, 2 ripstop sutures have been chosen here in a horizontal mattress configuration. A single triple-loaded anchor is chosen, 3 limbs are passed and tied down in a simple suture configuration. In tears with good mobility, but where an anatomic reduction is only achievable with a nonlinear tear reduction vector, an unlinked double row with an apex anchor may be chosen. We can see here that this is a nonlinear tear reduction vector, with the posterior rotator cuff wanting to turn the corner. A lateral row anchor at the apex of the footprint is then inserted, and simple sutures are passed and tied down. Then the medial row sutures are tied down and cut. In this complex tear, we can see the anterior supraspinatus does not reduce anatomically after the posterior cuff is repaired. The decision is then made to insert some ripstop sutures and perform a single row repair of the remaining anterior cuff. In order to utilize the most appropriate construct philosophy, consider these 4 steps. Step 1 is to assess tear mobility to determine whether the tendon edge reaches the footprint. If it does, step 2 is to consider whether it reduces anatomically to the footprint. If it does not, then consider a medialized single row repair. If it does reduce anatomically to the footprint, next assess the tear reduction vector. If this is nonlinear, then consider an unlinked double row repair using an apex anchor technique. If it's linear, then consider the optimal reduction vector and perform a linked double row repair with differential spacing of anchors and sutures to allow a shift to occur in the appropriate direction.